Hello everyone, I am Someshra Janapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So, in our previous classes, we have discussed about simply supported beam. We have already solved in lots of numericals on simply supported beam. Now, we will discuss about cantilever beam. So, you can see here AB is your cantilever beam. In case of cantilever beam, we know one end is supported and you can say it is fixed. Okay, one end is fixed and another end is free. So here AB is your cantilever beam. So in this class we will discuss. So if what will be the diagram of SFD and BMD in case we will apply different types of load. So first see if we apply one point load. Okay, if we apply one point load here at point B, that is W kilonewton, what will be the shear force diagram and bending moment diagram? So let's see here. If shear force is nothing but the total load, so the maximum shear force is going to be W kilonewton. Okay, and your diagram will be look like this. This will be linear throughout the length and it will be always positive. Okay. So next what? Here it is your SFD. Next is your BMD. What is your BMD? BMD is also nothing but multiplication of this total length, that is L, with shear force. So we will have the bending moment as WL kilonewton into meter, right? And you need to remember that always your bending moment diagram is going to be negative. Okay, it will look like this here, and you need to remember that it will be negative. It will join properly and the maximum bending moment is WL. Okay, at this support it will be 0. That means the minimum bending moment will be 0 and maximum bending moment will be W into L. Okay, here this is the shear force and bending moment diagram for what? Point load. Next we will see if we apply one UDL here. If uniformly distributed load is applied, that does mean the structure is looking like this. Okay, here it will be W kilonewton per meter. This is your point B, this is your point A. The shear force diagram will look like first thing we know shear force is always what? The load. Here you can see the load is here W kilonewton per meter. That means W into this total length, right? So the shear force will be W into L, right? It will be kilonewton. And this structure is also going to be like positive and what? It will be like this. Okay, positive and linear. This is your what? SFD. And to draw bending moment diagram, BMD will be what? Multiplication of shear force with the distance. It will be is negative. You can remember that the drawing will be parabolic. Okay. Here This is your positive, and it will be negative, and it will be WL square by 2. Okay, kilonewton into meter. Like your maximum bending moment is going to be WL square by 2, and here maximum shear force will be WL into WL kilonewton. It will, shear force is going to be like positive always, bending moment is always negative. It will vary while we change like left to right or right to left, but you can remember shear force is in positive and this is negative. Also, you need to remember while we are solving numericals on shear force about what UDL, so the structure will look like linear, but in case of BMT it will be parabolic. Okay. Next, cantilever beam with, let's see what, gradually varying load. Gradually varying load, that does mean it will be like, the load will be like this. Here it is at A, this is your B. Okay. So, this gradually varying load is nothing but W kilonewton per meter. And if we draw the shear force diagram and bending moment diagram, it will be, first thing is, this will be WL by 2. Shear force that will be maximum will be WL by 2, and it will be like this. Here your SFD will be parabolic, and you can remember that BMD is going to be cubic, and it will be like, this is going to be like your sort type of question, that BMD of gradually varying load, how it will look like? It will look like cubic in nature, and shear force diagram will be parabolic in nature. Shear force will be positive and this will be negative. Okay. Your maximum shear force value is going to be like WL by 2 kilonewton, and maximum bending moment will be WL square upon 6 kilonewton into meter. Okay. We need to remember these formulas, and as now we know what this formula for gradually varying load, formula for uniformly varying load, and point load. Now, if there will be different values, like in this W kilonewton, we put some values, we can easily calculate what, maximum shear force and maximum bending moment by putting the values here in case of this W and L. So now, if we just remember these three formulas, it will be very easy to solve any kind of numerical in case of cantilever beam. So in our next classes, we will solve lots of numerical on basis of application of point load, uniformly distributed load, and gradually varying load. So to solve those numericals, we need to stay tuned. Thank you so much.